More Java fundamentals. In this presentation, I'm going to talk about arithmetic operators, combined assignment operators, and conversion between primitive data types. The arithmetic operators that we can use in Java are plus, minus, asterisk, slash for division, and percent sign. The percent sign is the modulus symbol, and it gives you the remainder. Let's see. In this first example, I say x equals 5 times 2 modulus 3. So 5 times 2 is evaluated as 10. What is the remainder of dividing 10 by 3? 3 goes into 10 3 times and has a remainder of 1 left over. So x will get the value of 1. Now, the next statement is showing you that you can use a complex equation here, just combine different operators together. I am taking 2 multiplying math.pow, that's 4 comma 2, that's 4 squared. 2 times 4 squared plus whatever was in previously in x. I'm adding that and now storing that back into x. That's evaluated as 2 times 16, math.pow, 4 squared is 16, plus 1. That gives us 33 is stored back in x. X originally had 1 in there from the previous statement. Excuse me. And now I am storing the new data of 33 back into x. Well, there's a shortcut way of writing equations when you know the original value is going to be using an equation and you're going to store that back in the same memory cell. You can use plus equals, minus equal, asterisk equals, slash equals, and modulus equals. For instance, if I have x equals x plus 1, that's a shortcut way of writing that is, let's see, a shortcut way of writing that is x plus equals 1. So I'm going to take x, what's in x, add 1 to it, and store that back into x. Balance equals balance minus withdrawal. A shortcut way of writing that is balance minus equals withdrawal. For beginners, I just prefer you just write it all out. X equals x plus 1 and balance equals balance minus withdrawal. I'm just covering these assignment operators because they're mentioned in our chapter, section 2.6, combined assignment operators, so that you understand what's going on there. Conversion between primitive data types. Before a value is assigned to a variable, Java checks the data types to determine if they are compatible. Primitive data types are ranked. One data type outranks another if it can hold a larger number. Let's see what we mean. In this instance, I want to store a double into an integer memory cell. X has been declared an integer. So a memory cell large enough to hold an integer has been created, and I'm assigning the value 5 to x. Then y is a double, and a memory cell large enough to hold a double is allocated, and I'm storing 2.5 there. I get an error if I say x equals y. I'm trying to put 2.5 into an integer memory cell. I get an error when I compile. It gives us an error in conversion results in a compilation warning. Possible loss of precision. So I'm not able to do that. Now, if I really want to force it, I want to make sure that I can, I want to convert that double into an integer so I can store it. I can cast it. Casting allows you to manually convert a value. And what you do with casting is that you put the new data type in parentheses in front of the variable. So here, by placing int in parentheses in front of y, what that means is take the double variable 2.5 and convert that to an integer. The fractional part of the number is removed. It is truncated. It's lost. So what happens is 2 is stored in x. The 0.5 is lost. And just store the integer value, 2, in x. It doesn't round. You just completely remove the fractional part. So here I'm casting that double y into an integer so that I can store it in an int, and my program will be able to run and compile correctly. Now, what if I want to store an int into a double? Well, actually, there's not going to be a problem with that. X is 5, and Y is, I want to store the 5 in the Y, and it just converts that into a double 5.0. Is stored in Y. Widening conversion is okay. So I'm able to store an integer into a double. Now, what if I have mixed mathematical expressions here? Java strives to convert all operands to the same data type. So if I have 5 plus 2 times 2, what happens is it's going to be 5 plus 4. Now remember, it's pretty please my dear Aunt Sally, so it's going to do the multiplication first and then do the addition. And then the result is an integer 9. Now what if I have 5 plus 2.0 times 2? It actually has 5 plus 4.0. Now that's a double. Now when I have a double plus another integer, it results in a double. So the result is going to be a double 9.0. Whereas the first one was all integers, and that result was an integer 9. And the second one is the result is a double 9.0. Now what about division? Division by two int operators results in an int. 5 divided by 2 times 2.0. 5 divided by 2 actually gives us 2. Remember, the fractional part is automatically removed when I'm dividing by int. So integer division, it gives you an int. 5 divided by 2, it gives you the 2. It truncates off the fractional part. Then I multiply that by 2.0, and the result is 4.0. Now, at least one of the operands must be double to result in a double value. So if I had changed the 2 in the denominator to 2.0, 5 divided by 2.0 times 2. 5 divided by 2.0 gives me 2.5. Then I multiply that by 2, and I get the result of 5.0.